Hello everyone. Today I am going to discuss the third problem of Leetcode Weekly Contest 325, which is maximum tastiness of candy basket. So we are given an array of positive integers price, where price I denotes the price of ith candy and then positive integer k. So let's consider price as a. So we are given n integers. Let's say a1 up to an, and we are also given an integer k. Now what we have to do? The store sells a basket of k distinct candies. The tastiness of a candy basket is the smallest absolute difference of the prices of any two candies in the basket. So we have to pick key candies from this basket. So let's say we have to taken B1, B2 up to BK. Okay, B1, B2 up to BK. Now what we have to do? The tastiness of this. So let's call it as f of this. F of this array is nothing but absolute difference between Bi minus Bj. Okay, absolute difference between Bi minus Bj, and this will be the maximum of all these values in the subarray. This is the function. Now we have to choose the array B in such a way that this function, let's call it as G. Let's say G equals to maximum of Bi minus Bj, such that G is maximized. Okay, I think this will be minimum. So let's cancel it. Let's delete it. Mm, Delete this. This will be minimum. This is minimum, and we have to maximize the value this. So we have to maximum of G over all B's. Okay, I hope you got it. This is the problem. Now let's jump into some observations. So what is the first observation? Let's say we have taken an array. Let's say our array is 1, 3, 5, 12, 19. Now we have to take three elements from this. So let's say we have taken 12, 5 and 19. So what will be the minimum absolute difference between this array? Now if we sort the array, if we sort the B array, so 5, 12, 19, then after sorting the array, the minimum absolute difference between will be between any two integers, any two adjacent integers. Okay, so to find the minimum absolute difference, this the complexity of this will be order of n square. If we try to find over like the absolute difference between every pair, the complexity will be order of n square. Because we are finding minimum, we can just sort the array and take the absolute difference between only the adjacent ones. So our overall complexity will be order of n log n. Okay, why we are doing this? You can think about it in your spare time, that after the minimum absolute difference will be only between 512 and 519, because this absolute difference will be positive, greater than equals to 0, and this absolute difference will be also greater than equals to 0. So if we take any pair, let's say here we are taking I and j, the absolute difference will be obviously greater than this and or this. Okay, I hope you got it. Now let's jump into some other observations. Okay, now let's say we have this 1, 3, 5, 12 and 19. So no, let's take this example, 13, 5, 1, 8, 21, 2. Okay, 13, 5, 1, 8, 21 and 2. Okay, now let's sort this first, because I have already told that sorting will help us. So it will be 1, 2, 5, 8, 13 and 21. Okay, now what will be, let's say we are given that the absolute difference could be let's say, what is the answer? The answer is 8. So absolute difference could be 8. So what will be our picking strategy? The picking strategy will be, this is the second observation, you can make this as observation 2. The first observation I have already told, this is the observation 1, sorting. Now the observation 2 is the, if we have the absolute difference 8, what will be our picking strategy? The picking strategy will be, we will obviously take the first element, and now we'll just find 1 plus 8, which the element greater than equals to 1 plus 8, 9. So we'll take 13. Now we will take another element which is greater than equal to 13 plus 8, 21. So we will take 21. So this will be our picking strategy. We will take a0 after sorting, then take greater than equals to a0 plus 8. This is a1. Now again we will find greater than equals to a1 plus 8. This will be a2. I hope you got it. Now this is not given to us, right? 8 is not given to us, but if you think carefully, this is increasing function. Like if we take this as 7 and this as 8, so let's say we have taken 8. The count of integers we can take from this array, let's call it as f8. Now if we take 7, the count of integers will be f7. Now if we observe carefully, f7 will obviously be greater than f8, greater than equals to, obviously greater than equals to f8. Now let's take one case where k equals to, here we have considered 8 now, so let's consider it as 7. Okay, so if we take 7, we will take 1, let's consider this as 5. Okay, 5, because 7 will yield us the same answer, so I want to give you different answers. So if we consider the difference as 5, then the first element will be 1, the second element will be 8, the third element will be 13, and the fourth element will be 21. So we can take 4 elements, so we can obviously say f5 greater than equals to f8. Now if we take 7, so if we take 7, then it will be 1, 13, and 21, same. So f7 greater than equals to f8 also. So I hope you understand what is the second observation. So as this function f is increasing function, sorry, decreasing function, we can do binary search on it. Okay, so let's jump into the solution. So here n is the length of the prices, and first we are sorting the prices. Now what will be the maximum difference? The maximum difference will be nothing but the this 1 minus 21. 1 minus 21 will be the maximum answer. Let's say r k equals to 2. I hope you got it. So now L equals to 0 and R is prices n minus 1 minus prices 0 after sorting. So maximum minus minimum, nothing but maximum minus minimum, and answer equals to minus 1. Now we are just doing binary search here. Now if j equals to 1, j less than n, j plus plus, you have already taken the first element. This will consider the count of the elements, and this is the current element, or you can say last taken element. Okay, so if prices j minus car greater than equals to mint, so let's say our current element is 1 and we are at 13. Okay, we are at 13. Now we will check 13 minus 1, which is 12, greater than equals to 8, then we will take this element. So now the current element will be prices j, current element will be 13, and c will be incremented to 2. Now when we go to 21, now 21 minus 13, which is 8, greater than equals to 8, so c plus plus also. So now c is 3, c greater than equals to k, yes, c is 3 and k is 3. Now answer equals to mint, answer equals to 8, and this is the binary search, and at the end we are returning the answer. I hope you got the explanation. I will just provide the link of this code in the description box also. If you are benefited from this video, please like the video and subscribe to my channel. And if you have any doubt in any part of the video, please comment down what you did not understand from this video. I will try to reply each and every comment. And again, please like and subscribe.